Hi guys, in this video we should be able to finally complete the leg module. It took one video longer than the arm, but we went through a little bit more than what we just did on the arm. We went through the idea of making nodes more and more robust and intelligent by encapsulating things one inside the other. So last time we left it roughly here. So let me draw a new square. I'm gonna pick a color. Let's make this color here. So in the very last video we finished at this square, meaning that we have utility modules around here, 1 and 2. Then we have solvers that perform a unique operation, either IK or FK, and then a slightly bigger solver that encapsulates the two, which takes care of both operations. On top of that, it's leveraging the idea of switching between the two kinematics, and this again is to make sure that we can have a much more powerful function that is easy to drag and drop inside the graph. Now, with this done, I also mentioned that I would love to create another graph that sits above this one that is called leg module. And the reason is, ideally, the rig graph for me should be something that looks more like that. Okay, so it's just a forward solve with a very simple graph, which are the elements or the limbs that are in a standard biped. Again, if I get a leg module, then all these modules should be capable of adapting to any skeleton, not just skeleton with the same name and same orientation. But we'll see that in another video when we're going to talk more about unit tests. Let's jump into Unreal and let's see what we have here. Let's have a look first at the rig graph, which is increasing. It's adding features, but I'm adding features to the rig, but the graph does not change in complexity that much. So right now what we see here is a couple of things compared to last time. So we have, bear with me, we have an IK control, then we have, finally we added the toe control, then we added the heel control, and also the ball control. Now something to keep in mind is that this geometry here, I've used this geometry, you know very well. We're going to soon switch into a proper geometry. This geometry allows me to keep the focus on the rig rather than the deformation, because I don't want to be distracted by the deformation right now. Although there is a little bit of a caveat in this geometry. The foot here, if this is the the ankle, this is where ball control would be. It's kind of missing a bit of geometry here. Okay, so imagine that this piece is the end of the foot. This is where, let's say, you're halfway through the metacarpal. So when I were doing that, this piece will stay still. It's the classic foot ball behavior. Okay, so imagine that there is a little bit more geometry that goes from this control to this control. I apologize for that. And this was just a temporary geometry, and I forgot to update it. We can update it. I will update it later, so I will show what I mean exactly by this. Anyway, so we have these features, and because these features are specifically of the foot, I'm not embedding anything special in our previous solvers. This is something that is strictly related to the foot, this kind of three reverse control, reverse foot setup. So I am just simply adding the nodes to make this thing work directly inside the new module leg. So we can see that this foot is moving around, and if I set the leg into IK, everything still matches, and here instead I'm able to you can see the little piece at the end. This is meant to be a little bit longer, so it's not meant to be that short, but I will update the geometry later on. So this is pure FK, and see here. Let's reset that as well. Let's reset these. I'm pressing Ctrl G to reset controls. And here we have. On the other side, we do have the same thing, and this is just me testing that I can simply drag and drop, duplicate this node from the left side, move it, duplicate it, and just changing the L with the R's here, and everything still works. And this is the beauty of having powerful solver. Then it becomes really easy to connect things together like a Lego. But let's see what is how do we achieve this this thing. Let me compile so it resets everything. So how do we achieve this behavior? We're going to jump inside the module leg, but first let's see that in the module leg I've done basically all the attributes that we have discussed so far are in there, and on top of that there are a couple of more. There are the heel offset and the toe offset, and heel, toe and ball IK, as well as the metacarpal bone. So this is nothing to be worried about. These three controls are these three, and the metacarpal FK control is nothing else than the circle that moves this last bone. As a naming convention, I tend to use areas of the body. This is a little note. Areas of the body that are moving in IK, or meant to mostly be translated, are things such as shoulder or elbow. When you move your elbow, you're actually rotating and twisting two bones. You have the lower arm and the upper arm are rotating up. So the elbow is actually an area. It's not a bone per se. It's more like conceptually, I'm saying. While instead in FK, what I'm using is the actual bone names. So yeah, that's the main difference. But just so you know, the metacarpal control is nothing else than this bone here. Let's see. Let's go back to FK. Sorry, to IK. So another thing I've started doing in this high-level module, we're not going to go higher than this. I like the fact that now we have a module leg. I'm not going to create anything anymore. This is the final result when it comes to encapsulation. This is it. One thing I started doing is you start seeing that because this is something that is strictly related to the leg. Let me drag and drop a solver IK. I want to show you the difference. In the solver IK FK, because this is generic, the names of the inputs are very generic. But in theory, the user, once the system is complete, should never see this one, right? Or it's generic enough that they can use it everywhere in a generic context. And because it's a leg, the inputs now are named properly. Of course, the upper leg bone is inside the solver is connected to the start bone of the solver IKFK. But from a user perspective, because this is a leg, these are named after things that make sense for a leg. Another thing I added is these two separators. These are nothing else than Boolean controls, but they do nothing. This is just to have a nice separation in color between the bones input, the controls IK input, and the controls FK input. That's pretty much it. There is no reason. These three things do absolutely nothing. And I thought that was nice. Maybe eventually Epic Games will add some kind, or maybe already exists and I don't know. I couldn't find it. There is a nice way to have separators as a display options, so you can have a nice clean separation line. So okay, enough with the chit chat and let's jump into it. So this is the module leg, and as I said, is the last one of is the last iteration of the encapsulation. So we're never going to go higher than this. Let's see how it looks. We have plenty of inputs, of course, but all these inputs are nothing else than a duplicate of the inputs of the various solvers that I'm using. They only have different names. Pull vector offset, pull vector primary axis, secondary axis, IK stretch is the same. Pull vector offset, primary axis, IK stretch, they are simply directly connected. There's nothing. So if we, as any solver that I've made so far, the first thing that happens is a sequence, and then it asks, are we in setup mode? And setup mode is driven by setup. This is always the same, guys, everywhere. If it's true, let's keep this graph for a minute. Let's jump into here. I'm going to explain this in a minute, what this does. But basically, if you are in setup mode, simply run the solver IKFK in setup mode. Okay? So here, setup mode, orient FK to controls. This is exactly one-to-one what was happening in the other video. Ooh, I forgot to connect pull vector offset. Live bug. Okay, so let me compile and save. Come on. So this is nothing else than exactly the previous video. The additional graph that is in here is simply taking care of the additional functionality, finally, the reverse foot. So basically you can think that this is the reverse foot setup mode. Okay? Now the reverse foot setup mode, it's slightly more I wouldn't say sophisticated, but it requires a little bit more attention, and please bear with me. So these three controls, so far all the controls that we have placed somehow were calculated based on bone position, with the exception of the pull vector. But the pull vector was calculated based on an angle. Okay? But these three controls do not, in these three controls, only one really needs to be in the perfect bone position. The other two actually needs to be placed mostly around the geometry. Okay, and what if we don't have a geometry? Right now we are building a generic module. We don't know how the geometry will look like. So the idea here is that these three controls, 1, 2, 3, which are children of this guy, which is the main IK control, these three controls need somehow a way to be placed procedurally based on certain user inputs, because we cannot assume that the geometry ends where we think it ends. The only known quantity is where this ball joint is, because there are skeletons where the ball joint ends with an end ball joint with an end foot, and that might give you a hint of where the geometry ends. But depending on the pipeline that you're using, some skeleton, due to motion capture reason or for simplicity, they end here, because we don't need that at the end. We only need a pivot there rather than a joint, which makes perfect sense. And the same goes for the heel. The heel, this control here basically should be roughly where your heel touches the ground. But what if the character has shoes, or a different kind of foot, or the foot is very long? We cannot assume where this pivot is. So what do? We allow the user to shift this around based on an initial position. Now let's have a look a little bit about the hierarchy. So this is where reverse foot, or you know very well that I've explained myself. Reverse foot comes from a different reason, but from now on I'm gonna call like everybody else. The reverse foot setup, it's very simple. It's based on smart hierarchy rather than anything else. We have the foot, and the first thing we have is the heel. The heel moves pretty much everything because it is the parent of these two. Okay. Then you may think that we have the toe, but we don't. The toe is actually, sorry, the ball is actually the last. So we have heel, let's rotate this guy, both of them come together. Then we have the toe, and only its child comes through. And you can see that by using this control here, I'm lifting this area here. And then we have the ball. The ball is pivoting from there. You have to imagine that there is a straight line here, so you get a foot that is bent, like if you're standing on your toes. This is the effect that you would get if I had the proper geometry. So by reversing the hierarchy, instead of going boom, 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 is going foot, heel, toe, ball. So it's reversed here. It's like reverse. So how do we, now that we know this hierarchy here, how do we place these controls procedurally? Well, you can do it many ways. You can allow the user to move guides around, but again, I want to mostly rely on the bones, and then, with some exceptions. So this is where this piece of graph comes into play. Basically, what I'm doing here, if I highlight this, I'm getting the transform of this bone, so this little thing here, and I'm placing the heel. So this guy, at this moment, it's on top of here. But because these children are underneath him, all the three of them are in here, on top of here. Then I am adding the output of this control offset, which happens to be the heel control, to a vector. And the vector is called heel offset. And this is basically the value that the user would specify. Because I cannot safely assume that, sorry, let me do this. I cannot safely assume that, bear with me, I just want to show. I just want to show this thing moving. Oh, there is a reason why the controls went red. We're going to see it in a minute. I cannot assume where the geometry ends, right? So if I place, let's say, no, let's do -50 and 50. Let me get rid of that and compile it. You can see that these have been shifted. So this value represents the offset from this bone here. So in this case, I can decide to place this wherever I want procedurally, so to match the geometry. If I were to have geometry here, I would move this value to the point that where it actually goes. Does that make sense? So let me restore everything. Okay, and then we go here. This was something around -15, so the heel goes back -15 units from the ball origin, and the toe goes forwards 15 units. Let me compile it. Come on. Nope. Okay, so the distance between this bone and this bone, it's -15. And you can see the roughly, because this guy, it's 15 units forward, the distance that is from here to here is the same distance from here to here. But those two values doesn't have to be the same. So this is the way I'm doing to properly place these two things. I'm setting them, all the three of them, at this very center point, and then two of them, I'm shifting them. All right? And I'm shifting them adding a vector. The vector is an input. The first is the heel offset, I'm taking the control offset, I'm adding a vector, and I'm setting the control offset again, but with that vector in it. Same goes for the toe control placement here. So I'm taking the control offset, and I'm adding this other vector. And when it comes to the ball control, I'm simply leaving it there. So it's just a set control because I want it to be at the center. And then at the very end, I am placing, this is a very simple thing, I'm placing the metacarpal, which is the FK, this guy, to the same position. That's it. That's pretty much it. This is the entire setup mode for, sorry, not these two nodes. This is the entire setup mode for the foot. What if we are not in setup mode? Well, in setup mode, if not, we are simply solving IKFK. It's basically a copy of the previous regraph, the one that we did in the previous video. I'm passing all the values, start, mid, end, start, end, pole vector, all of those from the input, and I'm saying I don't want to happen in setup mode. The only additional thing that I'm doing is taking care on the FK matching of these additional controls. So I'm checking, are we in IK or in FK? By checking the switch attribute here. Are we in IK or FK? If we are in IK, we reposition the IK foot control and the IK ball control. Of course, if we want, remember, we want that when I am in FK and I'm moving these things, if I switch back to IK, everything should still work. So what I'm doing, I'm basically taking the bone and what is this set bone? Oh yeah, this is the metacarpal, sorry. I'm getting the transformation of the bone and I'm setting transformation of the control based on the bone. That's pretty much it. It's always the same. In here, this is because we are in IK, I'm saying this bone needs to follow this control. So if I go here, let me explain that a little bit better. So in here, I have the ball bone, right? It is following the metacarpal, because this graph here being false, it means that the graph now is in FK mode, so I want the control to follow the bone. Okay, so what happens if we switch and the graph is true? We do the opposite. We make the control of the metacarpal control follow the bone. Okay, there is nothing new here, guys. This is basically switching between having the bone driving the controls or the controls that are driving the bone. That's why I'm skipping it, because I don't want to repeat myself too much. I know that otherwise it gets too boring. But this is nothing else that, if we're doing this, is basically a very quick implementation of the follow mode in the solver. But I'm not creating a specific function or anything, because this graph here only need to exist at the module leg level. This is specifically for legs, in this case actually foot. So I'm not doing anything there. I have no needs to encapsulate this, because this I will never use anywhere else, if that makes sense. So the last thing I want to mention is this. In setup mode, and remember, the setup mode is where I'm placing my controls. Everything here works. The controls goes into place. But there is, for the first time, there is a difference between the inputs of the solver IK and FK. And this should prove to you that because the solver IK-FK has been built generic enough, this is the reason why this system works, even if the inputs are different. Let me show you. If I'm gonna try to show you the best way I can. So this is the setup mode, and this is the actual solver. Setup mode is responsible for placing the controls. So let's have a look. The start bone is actually the upper leg bone. Nothing weird there. It's this guy here. The mid bone is the knee. The end bone is the ankle over there. Now, start IK control is the hip IK control, this guy here. Mid IK is the knee, which is that, mid control. Now, the end IK control, you can see that when it comes to the setup is the foot IK control, right? It's this guy here. But this is there only because I want to position this guy in this specific place. When it comes to actual solving, this is the only bone that is different, because I don't want this control to drive the IK. I want this control to drive the IK. Okay? You can see that when I rotate this, nothing happens here, because this, if I move that, everything moves because ball control is the children. All right? So the only difference between these two, apart from being setup mode or not setup mode, is actually the end IK control. And you can see that instead of plugging in the end IK control the foot, in the normal mode I am plugging the ball IK control, which happens to be this guy here. So, but because the solver is generic enough, you can decide to plug any control, and from that point on, that control will drive the IK solving, even if it's a different pivot. So this is, hopefully this will tell you that this is why I took my time to build solvers upon solvers and study the idea of being able to orient controls or not orient them, or using project to new parent. All of that is because so I'm able to plug and plug different things at different times, and everything should still work and make sense. So that is that's why it's so important to me that this concept, it's constantly being explained. So I know that I've said that many times, but this is, now that we starting building more and more complex things, because the core, it's a little bit more robust, everything that we do above becomes simpler and simpler. So this is it. So we have a leg that goes there. It can switch between IK and FK seamlessly. So we can move IK FK. The last bit, and this is just something that I wanted to add because it's another way to show you proceduralism. I think it's a cool function, and is the reason why the previously the controls became red, or they are now blue and red, but previously they were just red. And this has to do with the fact that previously I disabled this function here. So this function here, I started adding it in my core functions because I found you may have noticed that I found really annoying placing manually controls. I found also really annoying to set the colors of the controls. So what I built, it's a function. It's very, very, very simple, and it sets a collection of controls based on a certain color. It sets this color based on a certain label that sits within the controls. So what that means is that if you contain _L and you are of type control, then please assign this color to everything that is _L_. If you are R, set the color to be red. If you are left, set the color to be blue. If you are centered or middle, set the color to be yellow in this case. If you are an extra control, and right now I'm using X, set the color to green. Now I've just noticed that this we don't need to change the color every iteration. This was a mistake. This actually needs to be not there, but this just needs to be in the setup mode. Live bugs. So let's move it here. So I just won't set the color once. I don't have to constantly set the colors for every tick of CPU. So let's see how this works very simply. So in the setup event, if I create a control, and because I'm creating a control, it's of type control, right? And this function here only works with controls. Right now I have a control that is a red sphere. If I set this to be my X control, you can see that it becomes green instantly. So if you have controls left and right and you have mirrored them, if you find a common label, you can color them. If I type this my M control, it becomes yellow. Okay, so this is why I built. Just by adding this node, I don't have to touch the color of anything, and still I will be able to identify between left and right, very simply because of the color scheme. And not only that, you can change the color on the go. So if you want this to be 0.5, you can see that. Well, now it's compiling, but boom, I've changed all the sides color in one go. This concludes the leg module. What I'm going to do next is I'm going to clean up the leg module and the arm module, and then I want to jump directly into unit tests. In the future, we're going to start adding, of course, we're going to talk about head, neck, and spine. The spine, I will leave it at the very end, because on that subject, we need to be really comfortable with the stuff that we've been doing so far. See ya.